In this video, we'll be going over sort color. So given array nums with n objects colored red, white, or blue, sort them in place so that the objects of the same color are adjacent, and the colors in order red, white, and blue. We will use the integers 0, 1, and 2 to represent the colors red, white, and blue respectively. So in our first example, we have 2, 0, 2, 1, 1, 0. When we sort them in place, we get 0, 0, 1, 1, 2, 2. And in our follow-up, we say, will you solve this problem without using the library sort function? Could you come up with a one-pass algorithm using only O of one constant space? Let's go over the thought process. The brute force approach will be to sort the input array using a built-in function. This approach will cost us O of n log n time complexity. Because of the sorting, we will need to find a more optimized approach. And in order to do this, we can implement a 3-pointer approach. So one pointer I will stay on the left side to populate values of zeros, because we want all the zeros to be on the left side. And then one pointer j will scan forward. And then one pointer k will stay on the right side to populate 2's, because we want all the values of 2's to be on the right side. Then when j finds a 0, we want to swap the elements at I and j. This will allow us to move the 0 to the left side. When j finds a 1, we will skip to the next index, because we want all the 1's to be in the center anyway, so we do not need to swap. And then when j finds a 2, we want to swap the elements at j and k, because we want to move all of the 2's to the right side. Let's go over the pseudocode. So I'm going to create three variables. So I, initially 0, to populate values of 0. It will initially start on the left side, and then j will also initially 0. It will be scanning forward. And k, so initially at the end of the array. So it's going to be nums down length minus 1. Now while j is less than k, this means we still have elements to process. If nums j is equal to 0, we want to move 0 to the left side, so we're going to swap the elements at I and j. Then we're going to increment both I and j. Then else if nums j is equal to 1, we do not want to swap, because 1 is supposed to stay in the center of the arrays anyway. So we just continue the next index. We're going to increment j. Else is going to be equal to a 2. We want to move the elements to the right side. So swap the elements at j and k. And then decrement k. We do not want to increment j here, because the element that's currently getting swapped here up to index j may be equal to a 2 or a 0. And we do not need to return the input array because we're doing it in place. So let's go over the time and space complexity. Time complexity is O of n, where n is the length of the input array. Is visit each index once. Space complexity is equal to O of 1. Now let's go over the code. So we're going to create our variables, our 3 pointers. And while j is less than or equal to k, we still have elements to process. If nums j is equal to 0, we want to move it to the left side. So we're going to say swap nums I and j. And after we swap, we can increment the 2 indices. Else if nums j is equal to 1, we can just increment j. Else we want to swap the elements inside j and k. So we're going to say swap j and k, and then we're going to decrement k after. And then let's create the method to swap. So the input array, and the two indices we want to swap, so we can call I and j. So we're going to create a variable temp to keep track of the current elements before we place it. Let me know if you have any questions in the comment section below.